right. So I'm a venture capitalist. I invest in a lot of machine learning driven companies, and I've thought a lot about the broader impact of machine learning on the economic landscape. And I'd just like to talk a little bit about what I see as the primary economic impacts of the machine learning revolution. It's a difficult question because the machine learning revolution is a moving target. I think we've all been impressed by the speed and breadth of machine learning's impact on different capabilities and intelligence generally, starting in the late 1990s, where I think we really reached a tipping point on gaming skills, which is really the first area where we saw significant machine learning capabilities. It started with Pong, and then Space Invaders, and then grew to chess. We all remember when Kasparov finally lost to Deeper Blue, and then more recently in Go. And we've had a steady progression up the levels of intelligence through mechanical skills, primarily the development of autonomous systems, autonomous driving in the early DARPA challenges, and then on to perception with the recent breakthroughs in machine learning. And I guess my assumption for this presentation is that we're going to continue to progress very rapidly. This target will continue to move. And there's some questions on how rapidly we'll progress into cognition and how applicable current deep learning approaches are to cognition. I think we will figure these out, and I think we've tended to be surprised at how rapidly this revolution has progressed. I don't think that'll change. The first major point of economic impact of the machine learning revolution is I think we're at the beginning of a very long and significant innovation boom. I think this will be a longer, more significant innovation boom than we had with the advent of the internet. And the scale and nature of the innovations will depend primarily on how much data you have. I think for those that don't have a lot of data, the revolution will primarily be manifest in the emergence of new building blocks for applications, new semantic and analytic services such as image recognition, speech recognition, reasoning and others to come, and these will enable people to improve their existing applications, but more importantly, they'll enable the creation of lots of new applications. And I think this impact is very deep and very broad, and we'll see lots of new companies that take advantage of all of these new semantic services and analytic services to build new applications. I think for those who have more data, they're able to optimize their applications. I'm sure many people in this room are doing that with any of a variety of machine learning optimization engines. I think where we'll see the most innovation is for those who have really immense amounts of data, whether they've created it themselves, whether they've aggregated it from others, or whether they've partnered with others to pool it. Machine learning enables, when you have that much data, the creation of categorical net new capabilities. This is exciting. This is something that's very different that I think we've seen historically in technology, where suddenly you can have a new capability such as autonomous driving with sufficient amounts of data. And Tesla seems to have gotten the most data and continues to innovate in that area. There is a company I've invested in called Dataminer that its particular art we had to come up with a name with prior to the press release of the financing, and we called it real-time information discovery. They have access to some of the largest real-time data sets in the world. They use that to identify the emerging digital signatures of events as they're starting to happen, their very first milliseconds. So in effect, they discovered news before it's news, and they now effectively are the news. They're the primary source of news for most major media organizations, and it's used in a variety of other verticals as well. I'm very excited about what machine learning can do in healthcare with disease diagnosis and with directed drug discovery. So again, I think the biggest innovations we'll see are in the creation of these net new capabilities, and that will lead to the creation of substantial new platforms. And my business is to try to find these platforms in their early stages and to invest in them and help them grow. And I think we'll see a lot of them. I think another fundamental economic impact of machine learning, and this I think may be the primary driving force of the nature of the machine learning revolution, in the same way that network effects were in the internet revolution. And I've written a very long blog on this. On my own blog, I published it on TechCrunch, that captures the manner in which machine learning generates increasing returns to scale, which is a sort of very rare economic phenomenon and a very powerful one when it's created, and certainly happened with the internet with network effects. And what's new and different under the sun, of course, is automated learning, the ability of software to learn with exposure to new data and become a higher value product, and to create that economic value effectively automatically. And I think this is reflected in the business world in learning effects. So network effects were an observation that as networks get bigger, they become more valuable. And as they become more valuable, they get bigger. And there's a natural virtuous cycle. I think we see that in machine learning. It is not automatic, as it is often in the case of network effects. It requires excellent execution, where as your product learns more, it becomes more valuable. And I think for companies that are able to complete that loop and take advantage of the greater product value to generate more data from new customers to increase their learning further still and innovate further and get more customers. Companies that are able to take advantage of this type of virtuous cycle, I think will be among the winners in the machine learning revolution. I think this type of dynamic is we'll see it most with products that are relatively narrow and that are driven primarily, as opposed to sort of in relatively small part, by machine learning. And as with network effects, I think it'll give rise to a number of runaway leaders, where this virtuous cycle goes so quickly that they learn and innovate not only faster than their competitors do, but faster than their competitors can. So we saw this in search with Google. And for anyone who tried to catch Google after it sort of passed escape velocity, it was a fool's errand. It was too late. They had a product that was so valuable, it was capturing more data than anyone could. They were learning more from any quantum of data than anyone else could when it came to search relevance. And I think we'll see the emergence of more of these runaway leaders. There's some interesting companies out there today where I think, you wonder, will this be a runaway leader? It certainly has some of the early markings. Tesla might be one. It's certainly getting access to more and more data as it has more and more cars. It's a complicated one because their value is not just the automated driving. It's a cool car. It's an electric car. And again, I think you'll see this most with relatively narrow products that are driven primarily by machine learning. I think there's another reason we'll see more monopolies in the machine learning revolution, which is that if software is egalitarian, machine learning is feudal. Of the three major components of machine learning, computing power, algorithms, and data, computing power and algorithms are basically commodities, or most of the workhorse algorithms are in the public domain, whereas data is proprietary and it has highly concentrated ownership. That's a very big deal. Whoever has the most data and is able to make use of it with machine learning will have an epic advantage over others. And again, if they take advantage of these learning effects, they can grow that data advantage over time. The fact that there's highly concentrated data ownership, data is not freely shared globally. If you look at who owns the data, there are these massive concentrations with the big internet platforms, probably with intelligence organizations, and large financial institutions. And I think it creates a natural tendency for monopolies. So when you add all this together, if I were to try to sort of summarize, if we look at the broad economic landscape in 5 years and 10 years, what will it look more like, combining these effects of a high degree of innovation and a high degree of natural monopolies? I think you end up with something that looks like innovative feudalism. And the two major impacts of machine learning will be at sort of two ends of the spectrum, for those who have lots of data and for those who don't have a lot of data. For those who don't have a lot of data, at the bottom here, which include consumers, enterprises, and technology vendors, I think play an interesting role as a subset, there will be a democratization of basic intelligence, and it will be reflected in the emergence of an increasing number of these semantic and analytic building blocks that I talked about earlier. At the other end of the spectrum, for those who have massive amounts of data either today or if they develop those massive amounts of data by creating new machine learning application that benefit from learning effects, they'll have the ability to generate capabilities that currently no one else has, and that unless someone has data similar to theirs, no one else will be able to develop. And some of those will relate to optimizing their core competences in the way that Amazon uses machine learning today around pricing, Netflix around recommendations, Google around search, Facebook around newsfeed relevance. But others will be orthogonal. I think Google in particular will develop some of these categorical net new capabilities that will just be stunning in virtue of all the data they control. And these two ends of the barbell are related. A subset of these big platforms are precisely the companies that are offering these new building block services to others in the economy. But the condition, of course, for these free or low-cost services is that they get back the data from these organizations in order to improve their intelligence further. This is a very feudal relationship. This is sort of like a feudal lord having serfs living on his property and enabling them to farm the property, but taking some portion of their produce as a result. And there's some very interesting and candidly some very concerning parts about this broad picture. But if I were to take a best guess on how the economic landscape will look, I think it'll look a lot more like this. I think we're seeing some interesting political reflections of this today in the discussions in Congress about the role of the major social platforms in the recent election. Another big point of impact that gets talked about a lot is automation. I think as human beings, when there's a new phenomenon, we first think, can it kill us? Can it hurt us? And then we think, well, can we stop it? And much of the discussion, I think, about automation has focused on those two things. And I think automation will fundamentally accelerate with machine learning. This is a plot developed by McKinsey. And the dots show all sorts of different professions, and they're plotted against the ability to automate the profession on the y-axis and the hourly wage on the x-axis. And it basically shows that automation is equal opportunity, that it will affect white-collar and blue-collar jobs alike. Some blue-collar jobs, such as groundskeeping or hairdressing, are particularly protected. It can be difficult to have machine learning pull those off anytime soon. And I think this is the type of analysis a lot of people look at and think, oh my gosh, we're all going to be automated. The future is one of universal basic income where we all stay at home and play video games and computers will do everything, which I think is a significant overstatement. But what's wrong with this kind of analysis, and what's wrong with a lot of the analysis of automation that I've seen in the press, interestingly, I think tech founders have put the fear of God into the rest of the world when it comes to automation, with future visions of universal basic income and staying home playing video games. What this misses is that this is a snapshot in time. I think when you think about automation, you have to think of the dimension of time. If you were able to show this as a movie over time, I think what you'd see is new dots appearing all the time and dots moving all over the place. The world adapts very rapidly to changes in technology, and while there are always dislocations, and I think the machine learning revolution will give rise to unusually significant dislocations, it's interesting to look back historically and think about what have other, if you really look deeply at other major points of automation in history, what happened? When there were these big dislocations, what happened? Interestingly, there have not been, big dips in employment around the Industrial Revolution, around the rise of personal computers. There was a lot of fear that there would be. The accounting profession was scared to death when personal computers came out. But something happened with them that we've seen happen in a couple of other historical examples. And I'll start with the automated loom in 1785. If you were a weaver, this was not a welcome development. There was a lot of concern that there would be mass unemployment of weavers, low wages for the remaining weavers because the machines were going to do all the work. There were protests by weavers. There were looms were vandalized and destroyed. This was something of great concern to this profession. So if you look at what actually happened, it was unexpected. What happened is that weavers ended up focusing on what the machines couldn't do, which was operating and maintaining the machines. And they were the best place to do this because they understood the weaving process. And productivity skyrocketed. You had this sort of man-machine combination, and there was a 98% drop in the amount of labor required per yard of cloth. And as a result of that, the price of cloth dropped, which dramatically increased demand for cloth, which quadrupled weaver jobs from 1830 to 1900. So interestingly, sort of precisely the opposite effect of what was feared. And we see a similar pattern with the ATM, the rise of the ATM in 1969. If you were a bank teller, this was not a welcome new event. There was concern that a lot of bank tellers would be put out of business. Banks were asked how they were going to deal with this, and there were discussions of the devaluing of employees and the dehumanization of banks. I think the latter remains a theme to this day. What actually happened was fascinating. The average number of tellers did indeed drop at banks from an average of 20 to an average of 13. But what that resulted in is it lowered the cost of operating a bank branch. And that led banks to open a lot more branches because it was cheaper to do so. And tellers ended up shifting their work from routine tasks, which the ATMs now did, of basically doling out money, to higher value tasks around sales and customer service. And again, they knew this industry well. They were well placed to do it. And the total bank teller jobs increased. Again, just the opposite of what was expected. And so I do not share apocalyptic views of automation driving us all to video games at home. I think this is part of a broader pattern that we've seen a lot historically. I do think the scale of the machine learning impact, the impact of the machine learning revolution will be greater than most revolutions we've seen. I think the internet revolution was another very big one. And I think the public debate around automation, again, which is naturally focused on how would we be negatively affected, which is totally natural, but it misses an important half of the story. So starting in the upper left here, I think we all know that AI accelerates automation and it radically improves prediction for certain tasks. As a result, it lowers the cost and the time required to perform those tasks. I think what's not generally captured in the public debate is the right-hand side of this slide. The lower cost and time required to perform the task increases demands for the task. It also increases demands for humans to do higher value adjacent work. If this were not true, we'd still be roasting rabbits as cavemen. I mean, we move up the value chain as technological improvements come. This also leads to an increase in demand for the core tasks, whether it's weaving or bank tasks, and leads to the creation of often far more jobs. This is not to say this is the prescription for everything that's going to happen with automation. There are very interesting and real questions of whether this time will be different and why. But I am optimistic in the mid to long term, and this is a contrarian position. But I think we've seen this pattern before, and I think we'll see it again. And I think the human labor will move to higher value tasks around what's being automated because there'll suddenly be more demand for it. The last example I'll give is when cars came along, buggy drivers obviously didn't like it. What cars did is they gave rise to massive new industries. The hospitality industry, hotels, motels, restaurants, were a relatively small industry prior to the advent of cars. So it's very difficult when you go back to the McKinsey slide of all the dots to think, if you just think of a snapshot in time, this is, these are the jobs that may go away, may be automated. It would be very difficult for anyone here who, or anyone, let's say, who's in their 60s or 70s to have predicted that their grandchildren might be cybersecurity specialists or video game designers. Those would be totally alien concepts to them. They wouldn't know what those would be new dots on the chart that they would have no way of predicting. And so I think we're heading into a world where there'll be lots of new dots, there'll be lots of automation around, there'll be lots of new job creation around automation. We will naturally move up the value chain. So with that, I'll stop. I think we have a couple minutes left in case there are any questions. Yeah. Yes, so it's a great question. I think there's a sort of chicken and egg problem or a data and model problem with machine learning startups. You need to bootstrap. You need to start with some quantum of data to be able to get ahead and benefit from these effects. I would argue that Google arguably was the first company that really did this. I think the public story of Google's rise was that PageRank was a fundamental, which is true, but to an extent, PageRank was a fundamentally different way of determining search relevance. But if you dig deeper, Google had the benefit of being embedded in the two largest data sets and perfect data sets for determining search relevance, which were AOL and Yahoo. And in addition to PageRank, it developed machine learning algorithms and started quite early. And today, they play a much bigger role in the determination of search relevance. So it was able to effectively provide a service to others that made it intelligent. And then it ended up competing with its partners, launched its own consumer front end. But I guess the point I'd make is that I think we have seen a couple examples of companies that have started from scratch and, as you say, built their value and aggregated their data primarily through non-machine learning methods, but then use that to use machine learning to add to their value. Tesla, I think, is the best example of that. But I think many companies I think there'll be a lot of enterprise applications. And I think, interestingly, security is the place where you're already starting to see the most with companies like Darktrace and Tanium, where there is a natural incentive on the part of enterprises to give their data to solve a collective problem. So please, if you can solve my spam problem, we saw this in email early on, take it. I'm not worried by the fact that this will benefit others. So I think you'll see a lot of enterprise companies, particularly ones that are focused on non-strategic data, and can provide a better service with collective data emerging. I think we're starting to, and we're seeing it across a variety of business functions. And then in healthcare, your question was, will machine learning be able to create significant economic value in healthcare? I see. It's a great question. I think you'll have to partner. I think that's an area where you don't want to spin up your own lab and have to incur those costs. But a lot of those companies can't make use of a lot of their data on their own, and many of them will recognize that for certain functions, if there is a company that provides a service, for example, in radiology, you can hire a lot of people to interpret radiology sort of products for you, or you can work with a company that pools a lot of data from your competitors around the country and is able to develop a more automated service that you all benefit from. And if you don't see sort of radiology as one of your defining strategic advantages, then I think that's something that you'd be open to if it helps everyone. I think we do one more question. Yeah.
So for an AI startup starting now, do you think in terms of strategy, you have a verticalized strategy where it's going after the specific domain and trying to collect data, the best data in that domain is a better approach, or going with APIs that's trying to collect a lot broader data sets across the board?
It's a great question. It's something I think about a lot. I think you can do both, but I think the way you ultimately win big in machine learning is to have some sort of proprietary data set or proprietary elements of data sets. You may aggregate other data, but some core that others do not have. I think you're most likely to get that if you number one, focus on a vertical, because the big horizontal players, whether consumer or enterprise, are going to be able to capture a lot of the broad horizontal data. You don't want to compete with Google or Facebook for consumer data. But if you go into agriculture or you go into some, industrial reading equipment, you may be able to work with a lot of customers, develop that sort of data advantage. And I think that's generally the way that you win big. Okay, time's up. But thank you very much. Appreciate it.